By changing the concentration, okay. What is the meaning of concentration here? What do you mean by that?
Ma'am, we have done this.
We have done this part. Fine. Well and good. Changing of temperature, we have done it.
Yes, ma'am.
Changing the rate of reaction.
No, ma'am, हमने surface area नहीं करा. Surface area से नहीं.
See, if we give the temperature to any of the material, okay, some material expands, some material contract according to their property. Some material, just like if I'm talking about the plastic, if this is a plastic, if I give the heat, the plastic reduces its shape, right?
Yes, ma'am.
Right? But if I will give the ice, if I'm taking the ice cube, okay, majority it reduces. Yes, it becomes what? Liquid in form. It expands. The molecule starts expanding its shape, and not exactly you can say it's expanding, it's changing its shape. Okay, so previously the molecules are very tightly packed, now it is becoming what? Loosely packed. Right? And if we give more heat, then it becomes what? Totally loosely packed, and then it becomes what? In gaseous in nature. Right?
Yes, ma'am.
So majority of the case, it reduces its shape. Now, if we are talking about the calcium carbonate when reacts with a hydrochloric acid, we have already studied what is exothermic and endothermic. What is exothermic?
When something is reacted, when heat is released in a reaction.
So that is what? Exo or endo?
Exo.
In endo?
Heat is absorbed from the surroundings.
Perfect. Perfect answer. So here in this experiment, when the calcium carbonate reacts with hydrochloric acid, okay, this is a displacement or double displacement. Which type or simple decomposition? Which type of reaction?
Is ma'am double displacement.
Can you please explain me how?
Because displacement is explained. I can't remember, but like so when we have two elements and when they react and two elements ही बन रहे हैं, so positive and negative ions.
यहाँ तो ज़्यादा बन रहे हैं.
Ma'am, but so if calcium carbonate is A and calcium is A and carbonate is B and at H2HCl is C. एक सेकंड मेरे को समझ नहीं आया, कंफ्यूज हो गई. H2 H is C and Cl is 2, तो फिर वो CaCl बन जाएगा and वो एक हो गया A and D and B and ये मेरे को नहीं समझ आया.
See, in a double decomposition, we know that A plus B minus plus C plus D minus, right? This tends to what? AD and BC. AD plus minus plus CD plus minus. Okay. Here what?
CB होगा.
अच्छा, sorry. CB. Sorry. Okay. Here it is what? CaCO3 plus minus plus HCl minus plus. So Ca combines with Cl. Ca combines with Cl. Now H combines with HNO3. H combines with HCO3 plus minus. Now this will undergo decomposition reaction. HCO3. Understood now? Now this part will go in the decomposition reaction. Then we get what? H2O plus CO2. Understood? Or shall I write it on the
Going through double displacement and decomposition.
This is Lakshit. Where is Lakshit? Yeah. Now see here, what will happen? Then when we add these two, okay? So this is your LHS, this is your RHS.
Yes, ma'am.
Ja. What happened?
What happened?
I don't know, sister. This is your LHS and this is your RHS.
Yes, ma'am.
Yeah, LHS, RHS. So CaCO3 plus SCl, okay, tends to CaCl. Acha, not tends to. I will write this one also. Otherwise, you will not. You will confuse. CO3 plus SCl plus HCO3, right?
Yes, ma'am.
This is there in the LHS. Now RHS. CaCl plus HCO3 plus H2O plus CO2. Now HCO3, SCO3 are in both. So obviously we will cancel each other.
Hmm.
The equation is not balanced. So forget about that, the balancing in nature. So what will be the output? CaCO3 plus
Three.
HCl tends to CaCl plus H2O plus CO2. Understand CaCl3.
Second CaCl.
Understood?
Also CaCl3.
And you have to balance it. Understood how it is making?
O2. Yes,
So
ma'am.
this is your double decomposition, double displacement, not decomposition. This is your double displacement reaction, and after that, it other further goes with the decomposition reaction.
Yes, ma'am. Okay.
Write it down.
Done. Written.
And after that, Lakshit, how to balance it. You know balancing of equation.
Yes, ma'am.
Sure, Lakshit, sure.
Yes, ma'am.
Balance it and then say, is
Yes,
it balanced or not? Is it balanced or not?
ma'am. No, ma'am. This equation which you have written is not balanced.
Now, what will be the thing we have to add or subtracting?
Ma'am, पहले तो we have to add 2 in front of HCl
Very good.
and 3 CCA.
Do the balancing. If you don't know, then I will explain it. Do the balancing. Ayo.
1 second.
This the unbalanced one is known as what? Acha, unbalanced equation is known as what?
I don't know.
That is known as what? Skeleton equation.
Skeleton equation.
Have you heard this word?
No.
That is known as skeleton equation.
Balanced equation is different.
And after the skeleton equation, everyone will give you a skeleton equation. Then you have to balance it. Then that is known as what? Balanced equation. Okay. Can you able to do, Lakshit?
Yes,
Shall I
so much.
explain it?
I'm doing it now.
Okay, so we have to add it here. Right?
Yes, ma'am.
Perfect answer. Sorry. Now, by changing the surface area, so this method you the place some marble in the flask and add the acid into it. Okay, wait a second.
That's CaCO3 plus HCl. Here you can see we have the solid, that white powder, that's the calcium carbonate. And then we drop the aqueous HCl, hydrochloric acid, right on that. And
This you can see here. You can see here bubbles are forming, right?
Yes.
So these bubbles are what is in the form of a heat. So this is a what exothermic reaction. Understood? Lakshay? So here also in the book also they have done the same experiment. They have just taken the marbles, that is the marble chips, as well as the, as well as the our calcium carbonate, okay, and then they have put the hydrochloric acid, and then we have plugged the cotton. So all the gases are coming out and stored in the cotton. Okay.
Okay.
We get calcium chloride, that's dissolved in the liquid, and carbon dioxide.
And that gas which is contained, which is in the cotton, that is your what? Calcium. Carbon dioxide gas. Okay.
Gas. Those are the bubbles you're seeing, and then some water. So this is the equation for the reaction of calcium carbonate with hydrochloric acid. And it's kind of important because when the ocean absorbs carbon dioxide, it produces a weak acid. It's not hydrochloric acid, but it's enough of an acid that it dissolves shells, like in the picture here, over time. It's called ocean acidification. So watch what happens when I take a shell, a seashell, and I put some hydrochloric acid on. Again, this is stronger than what would happen with ocean acidification, but you can see those bubbles? That's the carbon dioxide gas we saw earlier. That calcium carbonate, that shell, which is made of mostly calcium carbonate.
That's why in your book also they have taken what? Pebbles. Understood? Yes, pebbles. Because the pebble, that is also what, which is pebbles that is dipped in the water, that pebbles they have taken and put it in the flask with the hydrochloric acid. Because pebbles has a this property of absorbing the water, right? Correct. So when this experiment is happened, that time lot of carbon dioxide gas is evolving out. Now how to check this is a carbon dioxide? So when you take a fire, okay, and just tries to burn this cotton, that time cotton will not burn because we know that carbon dioxide is a bad conductor, right? Bad gas, right or wrong? Oxygen has to initiate the fire, but carbon dioxide has to stop the fire, right? That's right. So that is the experiment that is written it here. Clear this thing?
Yes, ma'am.
So these are the two things. When you are taking a large block of this one, mass is heavy of the pebble, then this is the way.
So, ma'am, when there is more surface area, there will be more less rate of more rate of reaction.
Correct. When there is only one, you can say, just like here in this experiment, they have taken what? Shell, right? If it is a one shell, then less carbon dioxide is there. But if there are 10 shells, what beta?
More rate of reaction.
More carbon dioxide will evolve out, not with the one shell, right? But if there are 10 shells, then more will be there, right?
Okay.
So the graph will also be what? More exothermic. After that, both will be the what? Stable. Here it is what? Stable, right? But here is less and here is more. That's it. Okay?
Okay.